What does it really mean for an AI to think? Today, we're diving deep into interview.net. Advanced C. The technical interview landscape has shifted. Senior .NET roles now demand deep C internals fluency, async internals. Memory management, expression trees, span not, superficial syntax knowledge fails. This is a strategic capability gap. But here's where it gets interesting. The fragmentation problem. Resources are scattered across blogs, docs, and outdated books. No unified system connects language features to runtime behavior. Candidates rehearse answers, not mental models. Interviewers detect shallow understanding in minutes. Existing prep methods are tactical, not architectural. So what's the real problem? Let's talk about root cause, linear learning. Traditional learning sequences features, not systems. Events delegates LINQ isolated sequential. The runtime's unified execution model remains invisible. Memory, threading, JIT, and type system are taught separately. This fractured view collapses under interview pressure. This raises a critical question, the breakthrough. A system-level interview framework. Map every C concept to a single runtime model layer. State machine async await. Virtual method table inheritance. GC generations IDisposable. Interviews answers become traceable architecture, not memorized trivia. Now let's zoom in on the runtime-centric system. 4 interconnected layers, type system and metadata memory and execution, concurrency and asynchrony code generation, and patterns. Every advanced C topic anchors to a layer. Questions become predictable. Explanations gain depth. Here's something most people overlook. Component breakdown. Async machinery, SynchronizationContext, TaskSeeder, IValueTaskSource. Memory internals, stack versus heap, struct tearing, finalization queue. LINQ architecture, expression trees, slough pipeline, deferred execution. SpanT and ref structs, safe stack-only types, runtime enforcement. Think about this for a second. The interview simulation engine. Realistic, scenario-based challenges. Each prompt targets a specific runtime layer. Follow-up probes test depth, not recall. Example, design a zero-allocation async parser. Forces span not pipelines, IValueTaskSource reasoning. And this is where things get complex. Diagnostic feedback loop, answers analyzed against the runtime model. Gaps mapped to specific system layers. Visual diff, your mental model versus the execution reality. Precision feedback, not generic tips. Iterative refinement built in. But here's where it gets interesting. The workflow. Assess current layer proficiency. Engage targeted system modules. Solve layer and chord challenges. Receive model diff feedback. Retest with runtime deep probes. Progressive depth across all 4 layers. So what's the real problem? Let's talk about measurable impact. Candidates report structural clarity, not more facts. Interviewers observe architecture-level reasoning. Answers flow from first principles. The JIT will devirtualize this call because time to offer compresses. Seniority signal becomes unmistakable. This raises a critical question, the new standard. Advanced C interviewing is now a solvable systems problem. No more hoping you've memorized the right obscure detail. You navigate the runtime's design. That is the difference between past and exceptional. Now let's zoom in on interview.net. Master the runtime. Own the interview, available now, advanced CTAT system-level preparation.